Walk through the halls of the American Museum of Natural History, and you're transported to other worlds, from the depths of the ocean to the African savanna to the age of the dinosaurs. But have you ever stopped to look not at the exhibits, but at the building that holds them? How do you architect a space for a creature that is 120 feet long and hasn't walked the Earth for 66 million years? How do you create the illusion of an endless horizon inside a windowless room? The AMNH isn't just a cabinet of curiosities, it's one of New York City's most complex and fascinating architectural projects. A constantly evolving puzzle where historic preservation meets cutting-edge science and engineering. Today, we go in behind the velvet ropes to uncover the structural and design secrets that make this museum a functioning machine for wonder. The museum's architecture tells a story of its own, a timeline of changing styles and ambitions. It began in the 1870s with a single Victorian Gothic building, now largely obscured by later additions. As its collections exploded, so did its footprint, resulting in a sprawling complex of interconnected buildings around multiple courtyards. The most iconic facades, like the Romanesque Revival entrance on Central Park West, were designed to project a sense of permanence and grandeur, a palace of science. But the real architectural innovation happened inside. The museum pioneered the use of the hall system, where each wing was dedicated to a specific theme, like the Hall of North American Mammals or the Hall of Ocean Life. This required a flexible yet monumental interior space, a pro tip for understanding museum architecture is to look up at the ceiling. You'll often see a network of steel trusses and skylights. These were the original daylighting systems, designed to flood the dioramas with natural, diffuse light, creating a more authentic and dynamic viewing experience before modern electric lighting was sophisticated enough. The challenge now, with modern conservation standards, is to block that same harmful UV light while preserving the historic intent. Now, let's talk about the most iconic resident, the massive blue whale model in the Hall of Ocean Life. Suspending a 94-foot-long, 21,000-pound fiberglass whale from a ceiling is a structural engineering challenge of the highest order. The whale isn't just hanging from a single hook. It is supported by a custom-engineered space frame truss system that is itself anchored to the building's primary steel structure. The engineers had to calculate not just the dead load of the model itself, but also account for potential seismic activity and the dynamic loads from the building settling and vibrating. The connection points are critical, using high-strength steel rods and custom-fabricated clevises to distribute the immense weight. A common and catastrophic mistake would be to attach such a load to a non-structural decorative ceiling. Furthermore, the whale's pose had to be meticulously planned. Its tail fluke appears to be diving. But that entire cantilevered section creates a complex moment force that the support system had to perfectly counterbalance. This is a perfect example of where sculpture, biology, and structural engineering become completely intertwined. Perhaps the most sophisticated engineering in the museum is completely invisible: the climate control and conservation infrastructure. Housing priceless, irreplaceable specimens like the Tyrannosaurus rex skeleton or delicate taxidermy requires a perfectly stable environment. Temperature and humidity are controlled to within a very narrow band to prevent materials from expanding, contracting, or degrading. This requires a massive building-wide hook system with redundant backups. The vibration from New York City's subway lines had to be studied and mitigated to prevent microscopic damage to the fossils over time. When designing a new exhibit or renovating an old one, a major workflow secret is the use of computational fluid dynamics or CFD software to model airflow within the display cases and the gallery at large, ensuring there are no dead spots or turbulent areas that could harm the specimens. This hidden, mechanical backbone is as important to the museum's mission as any single exhibit. The art of the diorama is another masterpiece of architectural illusion. These windows into ecosystems are not just stuffed animals in front of a painting, they are deep, three-dimensional sets. The foreground is filled with realistic vegetation and terrain, which blends seamlessly into a curved background painting, a technique perfected by artists like James Perry Wilson. The magic is in the forced perspective and the meticulously calibrated lighting, which eliminates any hard shadows that would break the illusion of depth. From a construction standpoint, each diorama is a custom-built vitrine, essentially a small, climate-controlled room with a giant window. The glass is often special low-iron, anti-reflective glass, and the seals must be perfect to maintain the internal environment. Designing these in a BIM model today would involve coordinating the structural support for the heavy landscaping, the electrical for the lighting, and the hook for the microclimate, all within the confines of a historic gallery. Finally, let's look at the future, with projects like the new Gilder Center. This recent addition is a stunning example of how modern architecture can dialogue with a historic campus. Its organic, cave-like structure, created using a technique called shotcrete, is not just an aesthetic choice. It's designed to improve visitor flow and create connections between previously disjointed galleries. This kind of project requires incredibly precise 3D modeling and coordination to interface with the existing masonry buildings, dealing with differential settlement and ensuring waterproofing at the newel junctions. It represents the next chapter in the museum's architectural life, one that continues to prioritize both spectacle and science. In conclusion, the American Museum of Natural History is a living, breathing architectural entity. It's a place where Victorian masonry meets fiberglass whales, where historic skylights are retrofitted with smart sensors, and where the engineering of a steel support beam is as crucial as the artistry of a painted horizon. It teaches us that the architecture of a museum is not just a container, but an active participant in the storytelling, a framework that must be both boldly monumental and invisibly precise. As a final disclaimer, the information in this video is based on public records and architectural principles. The specific engineering details of the museum's exhibits are complex and proprietary. This content is for educational purposes to illustrate the fascinating intersection of architecture, engineering, and museology. And for more deep dives into the built environment, please subscribe.